Hey everyone, it's Jim
And Charles
from Mellow Amps, and today in episode number 24 we're going to do an update on the new balanced preamp. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. So we are almost ready to order the PCBs for the new balanced preamp. But what did it take to get to this point, and how the heck do you design a PCB? And isn't point-to-point wiring better with 3 question marks? Well, the start in this case is easy to understand. We were deep into designing our new pure Class A solid-state monoblocks. And we settled, eventually, on what we think is a novel approach. But the only hitch is that it requires a balanced preamp to drive it.
Yeah, so we have to have 2 signals going into it, and one of them has to be inverted.
And we need some oomph behind those signals.
Yeah.
Now, the problem was we didn't have one. So, being keen designer builders, we designed one, built a prototype, rebuilt the prototype a couple of times, and shazam, we had a balanced preamp that we have since fallen in love with. Both for its functionality, it can take either an RCA or a balanced in, and it can do the same thing on the outputs. And I still goofed that one up. More importantly, the sonics are just stunning. Okay, so we've got a working schematic. Note, I didn't say a final schematic, and a working prototype. But how do we now make an MTA kit out of all of this? Well, here's the latest version of the schematic. Now, the circuit is big enough and complex enough that, believe it or not, it takes 4 schematics. So this is only part of the circuit. This is the core of it. We've got the gain stage and the cathode follower stage, but the phase inverting stage is missing, and the very complex input stages are also missing, as well as the power supply. They're all drawn, of course, or I couldn't have built the prototype. But don't build from this. It's literally fresh off the press. It's the latest version, and I haven't even had time to do a serious go through to make sure that there's no errors in the circuit. But after we start with a need in this case, and a sort of a design direction, we have to start with a schematic before we do anything else. In fact, other than those imaginings that we do in our mind, this is the foundation for virtually every piece of electronic gear out there, is a good detailed schematic. And I would suspect that most manufacturers would use that first schematic to build a prototype. So let's just drop in and take a quick look at the prototype and see, just how crazy a cobbled together prototype can look. Okay, well, this is the top. In fact, we had to extend the camera's position substantially, so our volume might even have changed a little bit, though we use a shotgun mic, which is aimed straight basically at our mouths. So this is the top, and that looks kind of neat and simple, right? Well, let's flip it over and we'll see just how neat and simple it is. Oh, actually, before I flip it over, I'll show you the back. The rear of the actual modern line build is going to be fairly similar, in which we have 2 pairs of balanced jacks, standard jacks, a pair in over here, and a pair outs over here. Okay, well, let's flip it over and we'll be right back. Okay, so this is what it looks like inside. It's a combination of, we made use of a PCB or part of a PCB that we already had, and I just sliced it off. It gave us the power supply, not all of it, but most of the circuit. And that made my life a lot easier as a prototype builder. You probably can see some signs that we've made some modifications. There's a snipped wire here. That's not a live wire, it's just a ground return. We just have to be really careful as to how we wire it up, particularly the ground return pass. We've got to really pay attention to that. You might think, wow, this is just insane. We've got a whole bunch of coupling caps coming straight into the Alps pot mini PCB. Charles is actually designing, or has designed, a larger breakout board or subboard for this 4-gang Alps pot, which, by the way, cost a small fortune, in which we'll have a good position for the coupling capacitors, so they won't be flying in the air like this. But this is actually probably fairly neat for a prototype. I like to build prototypes that are actually can be cleaned up, and somebody probably will buy this from us in the future. Now, I'm going to neatenize it a little bit. We'll put a bottom on it to make it safe. But it's actually worked flawlessly since we finished the last revision.
Yeah. I mean, considering the complexity of this, the lack of issues that we've had with it it's been great.
Yeah. Hopefully the circuit boards that you're designing for the modern line will be as reliable as this. Mm-hmm. I don't see why not, but you never know. You might have noticed that we've got some pretty heavy-looking cables shifting signals around. So over here, this is the input pair of XLR jacks coming along here, and then we have another pair of cables on the way out. And what this is actually Canair microphone cable. It's very high quality, balanced cable, and we're going to be actually using it in the kit version.
Not quite this much.
No.
We've optimized it a bit more.
Much shorter runs.
But the reason why we're using this is because of the shielding, right?
It's got excellent shielding. It's got very good specs. I mean, it's designed for professional use in studios and on stage. And as a result, it handles the signal extremely well. And if we can make it work, we do use another type of shielded cable that we like a lot. But if we can make this work, it can handle the balanced signal quite easily, because there's a twisted pair, the blue and the white wire, inside the cabling. And one of the things that I like to do is to try to reuse as much of the design and components in the final production version, because we don't want to change things. So, for example, the coupling capacitors, the resistors, the electrolytic capacitors, literally everything is going to be the same in the kit. Now, obviously, how everything gets laid out and interacts is going to be different, because there will only be some point-to-point wiring in the final kit, and most of it will be on the circuit board. So one of the questions I asked at the beginning was, isn't point-to-point wiring better? Yes and no. So if this was a very simple circuit and our components had very short paths, then we could point-to-point wire it and it would be perfect. Because point-to-point wiring around basically allows you to work in a 3D space.
Yep.
So you can see here the 3D space. So these are all B+ high voltage wires. We're coming up, we're crossing at a right angle, and we're maintaining distances between these B+ wires. You see how I fly it in and over? But take a look at the wire below it, the yellow twisted wires. Well, those are all filament wires. And even though they're DC, we really don't want them messing with they're low voltage DC. We really don't want them messing around with the high voltage DC. There shouldn't be a problem, but why take a chance? So in a point-to-point wired layout, if it's a very neat looking layout, there's a very good chance it's not a good layout. So one of the most famous modern designers of tube gear actually uses point-to-point wiring exclusively. But the problem for them is that because the layout determines the final sound of the products that they sell, they actually have to maintain a master layout amp. And everybody who builds that on the bench has to actually take the master down from the shelf and duplicate the layout.
Yep.
Everything, the wire positions, the height, the length, the whole thing. And for kit builders, it's not realistic. And frankly, it would be better, in my opinion and experience, to put a large PCB in the middle here, a larger version of this PCB over the Alps, and use strategic positions for point-to-point wiring. For example, we have to move the signal around some longer distances, relative to what a PCB trace would be, and we can't do it with a PCB trace. Same goes for the filament supply. It's actually going to be point-to-point wired, just because there's just no way to get it onto the board easily. So, anyways, that gives you an idea of what Charles started with.
Yep.
And I think you'll be impressed with what he came up with. So let's have some fun and bring the computer screen up live onto your feed. Okay, so everybody should be seeing Charles's laptop screen now.
Yeah, so this is the top side of the PCB in what's called a 2D view or a photo view. So it's sort of a simulated look of what it's going to look like whenever it's finished. And just like with the schematic that we were showing earlier, this is not the final version. There's probably going to be some small tweaks done to it.
Yeah, we've already done a complete review of the PCB once, and our rule is we do 3 complete passes.
And if we make any major changes, we have to do a full review of it after we do that.
Yeah.
Yeah. So this is the top side of the board. So this is the side that will be facing the top of the amp, and the sockets
We'll mount
on it, and we'll put a lot of the smaller components that don't need a lot of room. So we have a lot of small resistors. We have our diode array. Here's our switch bank for switching our inputs.
Hang on, why have you got so many bloody diodes?
Well, we've got a quasi-dual mono power supply, so we have one transformer, but after the transformer, it splits off into 2 completely independent power supplies.
Right, so it's almost like having 2 monoblock preamps, but actually there's 4 channels, aren't there?
Yeah, so it's like 4 monoblocks and 1 chassis.
Oh, wait a second. There's also a phase splitter circuit, so there's 2 more channels coming in on the RCA side.
Yeah.
So there's 6 channels.
Folks, when I tell you that this is the most complicated PCB that I've ever designed, please believe me.
Yeah, I mean, the actual circuit design only took a little while.
Yeah.
The initial drafting of it. But the devil, as they say?
And it's in the details. Let's take a look at the bottom side. We'll switch over to the actual design view in a minute, but take a look at what we've done here. We have these absolutely massive ground return traces. These are 5 millimeters wide. They're way oversized for what they need to be.
And that is so that we have essentially the lowest resistance possible. Basically what we want with the return pass is essentially an infinite amount of surface area for the return path. Essentially, we don't want the grounds to ever see any difference in resistance.
Right. We want everything to be at the same potential that should be at the same potential. And so they've been very strategically laid out with the grounds for the output stages going through the output over here, the grounds for the input.
Go slower with your cursor because it makes some people get dizzy.
Yeah, so the grounds for the input are also, are also linked to the preamp stages over here and the Alps pot. And the grounds for the power supply are all independent from that on their own.
So in a way, you've got strategically located star ground points.
Exactly, but integrated into the PCB.
And then they all come back to one point, don't they?
Right up here.
And what is right behind that?
That would be the IEC input and its ground lug.
Right. So there'll be a very short, heavy wire to link up the PCB to the IEC safety ground point.
Okay, let's switch over to the design view and get ready to be overwhelmed.
I don't think it's that bad. Okay, yeah, no, it is that bad.
So what we're actually seeing here is the top of the board and the bottom of the board, and the top board's labels and the bottom board's labels all displayed simultaneously.
And it's really the only way, when we're reviewing the circuit, it's the only way that we can actually make sure that there's no circuit errors.
So let's zoom in on one of the more complex parts here. I'm going to try to avoid running my mouse over traces because it's going to flash white whenever I do that. It's a little disorienting. But as you can see here, we have our inputs. We have an XLR right and an XLR left, and we have the pin numbers on here for them.
We also have the phase markings, though. Because we're looking at so many views all at the same time, the phase markings are sort of buried under the trace markings.
But they are going to stay consistent through the entire PCB. So that helps you match up where wires need to go. And if you're checking something, then you'll know which phase it's supposed to be in.
The other thing that makes it really tricky for us when we're reviewing it is that because of the way the writing or the labeling is displayed, we actually have all of our phase symbols are all flipped. So, for example, if you look over on the XLR write-in,
well, let me switch the view here so that you can actually see that. One moment. There we are.
Yeah, so you can see over on pin 2, which is always the hot or uninverted pin, it's actually displaying it as inverted. But in fact, the silk screening on the PCB will be flipped right over and it'll be non-inverted.
Yeah, because we're looking at a mirror right now, essentially.
Yeah, so that makes it a little bit trickier for us. But once you sort of get it, your brain programmed, it took me about, the first half hour to really get sort of oriented.
And it still catches us, yeah. So this is our whole input switch array. We've got our RCAs in, we've got our XLRs in.
And it's going to take 3 switches that will be ganged together.
And these are the wonderful little, what are they called? What's the name of that switch?
I forget what they're called, what the actual manufacturer name is, but they've got gold-plated contacts, and they're a micro switch with a long batten, which we need. And we first started using them on the Rocket Preamp, and they have worked. They're a little bit of a PETA to get on for inexperienced solderers, but they have functioned absolutely perfectly. They're just the best. They're not the cheapest by far. In fact, they're bloody expensive, but they are just the best switches. We have had no contact issues with them. They pass the signal perfectly. They've got a really what is it called? A high repetitive
something like
rating.
500,000 switches or something on them, maybe even more.
Yeah. So they're well worth spending the money. It's well worth our kit builders having to suffer. In fact, I think in this case we're going to build a holding assembly like we do for the RCA jacks to gang them all together in the right position, because they have to go through the top PCB pretty much exactly oriented. So we're going to have to figure out a way to key that holder on the board so that it literally holds them exactly in the right position. So luckily Charles can design something for our 3D printer, and that shouldn't be an issue. But yeah, I love those switches. As you can see all the traces coming to them, but you can also see that we're only using basically 2/3 or essentially 1/2 of the switching capability. And the reason for that is they don't make this switch in a smaller version. And frankly, having an extra set of pins works well with how everything is done here anyways. So
And these switches can also actually be put into a center off position to cut off both of the inputs as well, which is useful if you're trying to troubleshoot noise issues.
Yeah, and because they'll be ganged together, you'll be moving all three at the same time. So you don't have to, but I doubt if anybody is going to want to, have three switches to throw instead of just one.
So after we've got our input here, we come down to a nice bank of coupling capacitors, and in the point-to-point build we saw earlier, they were just sticking off the side of the Alps pot. So this is a little bit of a cleaner setup than that. And we have bypass jumpers for each one of them. If you know that you have a system where you're not going to be introducing DC into the circuit, and you have good tubes that aren't going to introduce DC backwards in the circuit. So we're a big fan of having as few components as possible in the signal chain, and so these are an option to be able to put in there if you know that it's safe.
Yeah, so, and it's an option that we'd like to just simply not have to include 4 extra quality coupling capacitors, but it doesn't make any sense to take a chance that somebody blows up a piece of gear. In the owner's manual, we put a serious warning there saying, if you like to roll junk tubes and scrounge stuff and change, put tubes in that the amp was never designed for, you're going to want those coupling capacitors in circuit, and they might save your bacon. We've managed to blow up how many DACs?
I think 2 now.
2? We're up to 2? Okay.
But they were expensive ones.
And I think we blew up half of another one.
Yeah.
Yeah. So, yeah. And so we've learned our lesson as well. Some of those explosions wouldn't have been avoidable, and some of them would have been with coupling capacitors. So now, what if there's a little change in here? Do we need to bring out a 1,000-page manual to figure out how to move a trace a little bit, Charles?
Oh no, it's actually quite easy. So let's take a look here. I'm going to zoom in, and let's say we weren't quite happy with the positioning of this trace right here. It's easy enough to just make a small adjustment just like that. And you can see that we try to keep very even spacing between traces, and when possible, if we want to stop them from interfering with each other, we try to keep even spacing and put them on the other side of the board. So the blue trace here is on the bottom and the red traces are on the top. So that gives it an extra layer of separation, especially with our really thick PCBs that we use.
Right. Yeah, we actually order the heaviest base stock for the PCB that the manufacturer can supply us, and we order the heaviest traces that they can supply us.
Yeah.
And if you've ever fumbled or worked on or reworked some other manufacturer's PCB and you've worked with ours, you'll realize right away, holy smokes, there's a difference here. There's like a huge difference. We have to pay for it, but the difference in cost at scale is not that much. Maybe we're paying an extra couple of dollars a PCB, and there's a number of PCBs in the kit. Like, how many are there? There's going to be 4 chassis, top and bottom, that's 6. There's the breakout board for the Alps, that's 7. The main PCB is 8. So I think there's 8. Yeah.
Is that right? 4, 5, 6? Yeah, that sounds right. 8.
So maybe it costs an extra $10 or $15 per kit. And then a little bit more at retail, of course.
But what that gets you is extremely good signal pathways, low resistance pathways, oversized traces.
A very sturdy board, so that when you push your tube in, the board doesn't flex and the tube just goes in solidly. It also means that board, our boards, will last an incredible length of time, maybe basically forever, unless you were to drop it into acid or
reworked it a dozen times. Yeah.
So, and in fact, we've reworked our boards and had to repair a few boards for customers over the years. And so long as you're just reasonably careful, you can rework the board a number of times, and you won't get into any trouble.
Yeah.
Well, I'm impressed, Charles. This is crazy. And reviewing it, do we review this whole thing all at once?
Oh yes. Well, we're tired and distracted, and the phone is ringing, and no, of course not.
Why don't you circle a section that we would do, like the inputs? We
Yeah.
would do this section here Yeah.
And that might take us half an hour to an hour to carefully go through and double check the labeling and all the trace positions. And
then I would want to look to see what comes out of that, what goes in and what comes out, and see where it's going, and just make sure that those traces, show them the two bottom traces where the signal is actually moving along the board.
So that's this guy right here and this guy right here.
Yeah.
So those are actually the RCAs that are going over to the phase splitter in the very middle.
Yeah.
And you can see we're running them on one side of the board, but we're also running them specifically underneath components, but at right angles, and those components will be lifted away from the board. So that's about as good as you can get unless you run a wire straight over, and this is essentially the same thing.
Yeah. So even though it doesn't look a lot like the point-to-point wire prototype build that I was showing you earlier, in many ways the way the board's laid out, designed and manufactured is actually very similar to a point-to-point wired circuit or build.
Just a lot neater.
Yeah. Now, years ago when I first started in electronics and, had my acid bath and had my resistive decals and stuff, God, I hated making PCBs. It was at home, making a PCB was not fun. And they used similar methods in small factories like ours as well. And we had one-sided PCBs back then. And now, I don't know how many we're up to. Our manufacturer goes up to, I think, 4 sides.
I think they're doing 8 now as well, but we're sticking with 2.
Yeah, well, I mean, to keep costs reasonable, if you don't need more than 2 sides, I think the shit board that we were looking at, the shit Freya, has 4 sides.
Probably 4, yeah, but it's kind of hard to tell whenever they're sandwiching them.
Yeah, they're so thin that we'd have to really put a microscope on the edges to even tell. But there's definitely more than 2 because there's circuits buried in between the layers.
Yeah.
So it's a lot easier actually to troubleshoot and lay out the board in a 2-layer board, one on top, one on the bottom. So if you don't need more complexity than that, why ask for it?
Mm-hmm.
Okay, well, I guess the next step, Charles, is to finish the review, design the rest of the boards for the kit, and then we'll be ordering hopefully next week sometime.
And then after that, we're going to build a second prototype, a production prototype, and then we're going to start calling for test builders.
And that reminds me, we've got test builders on the list already. In fact, the first time we mentioned this kit, people were sending an email saying, put me on the test builder list, please. Now, we will put you on if you contact us, but this is important. This is going to be the highest level of experience required to build our kits. If you've built any one of our MTA kits in the past and you've done it successfully without having to send it to us to clean it up, then you would qualify as an experienced builder. But if you've never done anything as complex as this, don't imagine that you could successfully build this without more experience. You won't. And we'll end up having to troubleshoot it for you. And frankly, we're just way too busy to do a lot of this kind of work. We do it. We actually do it as a free service to our builders. And we do it as quickly as we can. And it doesn't happen actually very often. I think we've only had 2, maybe 3 kits need help.
Yeah, and that's what we're trying to do with the design work, is to make it as easy as possible. But just because of the sheer number of components on this, the complexity is a lot higher. There's just more chances for something to go wrong.
Yeah, I mean, even installing those 3 micro switches, if you don't have a lot of soldering experience, you're gonna bugger it up. And then you don't have anything. The circuit won't function properly. So, yeah, you got to get, everything has to be done well, and troubleshooting it is going to be trickier than an average kit. So, yep. So, this is Jim
and Charles
signing off. Cheers, everyone.